Okay. So far it is clear, right, for everyone? So now we look at the third case. So what is the third case telling me? Huh? The third case is like this. Same again at the focus ಇವಾಗ. ಇಷ್ಟೊತ್ತು ಏನ್ ಮಾಡಿದೆ ನಾನು between the center and the focus ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ಅಲ್ವಾ? Now what I am doing is I am keeping it at the focus. So when I keep it at the focus, what is happening? Two rays I'm considering. One is parallel to the principal axis. It will again pass through the focus. Next, what I'm doing is I'm considering a line that is passing through the center of curvature. ಅವಾಗ ಏನಾಗ್ತಿದೆ ಅದು ಸೇಮ್ ಥಿಂಗ್. ಈ ಎರಡೂ ರೇಸ್ ಪ್ಯಾರಲಲ್ ಆಗಿದೆ. ಸಿನ್ಸ್ ದೀಸ್ ಟೂ ರೇಸ್ ಆರ್ ಪ್ಯಾರಲಲ್, ವಾಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್? ಸಿನ್ಸ್ ದೀಸ್ ಟೂ ರೇಸ್ ಆರ್ ಪ್ಯಾರಲಲ್, ಐ ಆಮ್ ಗೆಟ್ಟಿಂಗ್ ಅನ್ ಆಬ್ಜೆಕ್ಟ್ ಅಟ್ ಇನ್ಫಿನಿಟಿ. ಎಲ್ಲೂ ಹೋಗ್ಬಿಟ್ಟು ಅದು ಕನೆಕ್ಟ್ ಆಗ್ತಿಲ್ಲ. If it is not connecting anywhere, I won't know where to mark the object at. Correct? Do I know it? No, I don't. So that is why now what is happening? The place where I am marking it is, I can't mark it anywhere. So since it is parallel, image will be formed at infinity. The same thing is again happening when I'm keeping it between the pole and the pole is what? Pole is the center of the mirror, right? If I'm keeping it there, then also if I'm keeping it between the focus and the pole, then also it is coming like that only. Okay, so far so good. Everybody understood what are the different cases of reflection in a concave mirror? Everybody give me a thumbs up if you understood the topic. Do it quickly. Come on, fast. So I hope everybody understood the topic. Yes, excellent. So far it is pretty straightforward and simple, right? Moving on. I have an object between the focus and the pole. This is what I said just now. If I'm having the object there, what will happen? So take a careful look at the picture. If you look at the picture, you can notice that I have again taken two rays only. The first ray is reflecting in the mirror in such a way that it is passing through the center of curvature. The second ray that I am taking is incidenting on the pole and it will reflect from the pole. Okay, so now what I will do is I will extend whatever rays I'm taking. You'll notice real image, there's no option to form real image at all. Correct. Is there an option to form a real image? No option. Why is there no option? Because these two are again going too far away. They're not connecting anywhere. So that's why. Now what I will do is I will just extend it backwards. ಏನ್ ಮಾಡ್ತಾ ಇದೀನಿ ನಾನು ಅದನ್ನ ಬ್ಯಾಕ್ವರ್ಡ್ಸ್ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ತಾ ಇದೀನಿ. ಅದೇ ಪಾತ್ ನಾನೇನೆ ರಿಫ್ಲೆಕ್ಟ್ ಆದ್ಮೇಲೆ ಮುಂದಕ್ಕೆ ಹೋಗುತ್ತಲ್ವಾ, ಅದನ್ನ ಹಿಂದಕ್ಕೆ ಬಂದ್ರೆ ಹೆಂಗಿರುತ್ತೆ ಅಂತ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ತಾ ಇದೀನಿ. ಆತರ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತಿದೆ? I can notice here that I am getting an image which is imaginary. This is called as a virtual image. What kind of image is this? It's a virtual image and it is erect. Okay, it is a virtual image and it is erect image. So this kind of image is what I'm getting when I'm placing it between the focus and the pole. This is the only case in the concave mirror where I'm getting the image as a virtual image. ಇದೊಂದು ಕೇಸ್ ಬಿಟ್ಟು ಬೇರೆ ಯಾವ್ದು ನಂಗೆ ವರ್ಚುವಲ್ ಇಮೇಜೇ ಬರೋದಿಲ್ಲ. ಎಲ್ಲಾನು ರಿಯಲ್ ಇಮೇಜೇ ಇರುತ್ತೆ ಅಥವಾ ಇನ್ಫಿನಿಟಿನೇ ಇರುತ್ತೆ, ಇಮೇಜ್ ನೋಡೋದಕ್ಕೆ ಆಗುತ್ತೆ. ಸೊ ದೀಸ್ ಆರ್ ದ ಕೇಸಸ್ ದಟ್ ಐ ಹ್ಯಾವ್. ಓಕೆ, ಇದಿಷ್ಟು ನಾವ್ ಇಷ್ಟೊತ್ತು ಏನ್ ನೋಡಿದ್ವಿ? ಕಾನ್ಕೇವ್ ಮಿರರ್ ನಲ್ಲಿ ರಿಫ್ಲೆಕ್ಷನ್ ಹೇಗಾಗುತ್ತೆ ಅಂತ ನೋಡಿದ್ವಿ. ಕರೆಕ್ಟಾ? Now we will see what will happen here. Now what is the type of image that we have? The previous image ಏನಿದೆ ಅದು ಯಾವ ತರ ಇತ್ತು? When I'm placing the object at infinity, I had the image at the focus. And what was the characteristic of the image, it was an inverted image, it is a real image. ಇಲ್ಲಿ ಎಲ್ಲಾನು ಇನ್ವರ್ಟೆಡ್ ಇಮೇಜ್ ಮತ್ತೆ ರಿಯಲ್ ಇಮೇಜ್ ಆಸ್ ಐ ಟೋಲ್ಡ್ ಯು ಜಸ್ಟ್ ನೌ. ಆದ್ರೆ ಅದರ ಸೈಜ್ ಏನಾಗಿತ್ತು, ಹೈಲಿ ಡಿಮಿನಿಶ್ಡ್ ಅಂಡ್ ಪಾಯಿಂಟ್ ಸೈಜ್ ಆಬ್ಜೆಕ್ಟ್ ಅದು, ಸಾರಿ ಪಾಯಿಂಟ್ ಸೈಜ್ ಇಮೇಜ್ ಅದು. ನೆಕ್ಸ್ಟ್ ಸಿಗಿನ ಒಂದು ಸ್ವಲ್ಪ ದೂರ ಇಟ್ಟಾಗ ಏನಾಯ್ತು, ದ ಇಮೇಜ್ ದಟ್ ಐ ಗಾಟ್ ವಾಸ್ ಬಿಟ್ವೀನ್ ಫೋಕಸ್ ಅಂಡ್ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಅಂಡ್ ದ ಸೈಜ್ ಆಫ್ ದ ಇಮೇಜ್ ವಾಸ್ ಡಿಮಿನಿಶ್ಡ್ ಅಂಡ್ ದ ನೇಚರ್ ಆಫ್ ದ ಇಮೇಜ್ ವಾಸ್ ಅಗೇನ್ ಇನ್ವರ್ಟೆಡ್ ಅಂಡ್ ರಿಯಲ್. ನಾನು ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಅಲ್ಲಿ ಇಮೇಜ್ ನ ಇಟ್ಟರೆ ಐ ಆಮ್ ಕೀಪಿಂಗ್ ದ ಇಮೇಜ್ ಅಟ್ ದ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್, ಐ ಗೆಟ್ ದ ಇಮೇಜ್ ಆಲ್ಸೋ ಅಟ್ ದ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್. ಆಬ್ಜೆಕ್ಟ್ ಅಲ್ಲಿ ಇದೆ, ಇಮೇಜ್ ಕೂಡ ಅಲ್ಲೇ ಇದೆ. ಆಮೇಲೆ ಸೈಜ್ ಆಫ್ ದ ಇಮೇಜ್ ಏನಾಯ್ತು, ಸೇಮ್ ಸೈಜ್, ಅಂಡ್ ದ ನೇಚರ್ ಆಫ್ ದ ಇಮೇಜ್ ಇಸ್ ಇನ್ವರ್ಟೆಡ್ ಅಂಡ್ ರಿಯಲ್. If it is between center and focus, if it is between center of curvature and focus, I am getting the object beyond C. Okay, beyond C andre C na ದಾಟಿ ಹಿಂದಕ್ಕೆ ಹೋಗಿ ಇದೆ ಇಮೇಜ್ ಅಂತ. So size of the image is enlarged, ದೊಡ್ಡದಾಗಿದೆ. ಆಮೇಲೆ nature of image is inverted and real. If I am keeping it at focus, the image form is at infinity. So this image is highly enlarged. What kind of image is this? Highly enlarged. Why? Because the image is being formed at infinity. Infinity ನಲ್ಲಿ image form ಆಗ್ತಿದೆ, ಅದಕ್ಕೆ ಅದೇನಾಗಿದೆ, ಅದು highly enlarged image ಆಗಿದೆ. Next one, what do we have? Inverted and real. Highly enlarged image ಕೂಡ inverted ಆಗಿರುತ್ತೆ ಮತ್ತೆ real ಆಗಿ ಇರುತ್ತೆ. Next, what is the last and final case? Take a look at this case. How does it look like? What is happening here? I'm keeping the image between focus and pole. ಫೋಕಸ್ ಮತ್ತೆ ಪೋಲ್ ಮಧ್ಯದಲ್ಲಿ ಇಮೇಜ್ ನ ಇಟ್ಟಾಗ ಏನಾಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಐ ಆಮ್ ಗೆಟ್ಟಿಂಗ್ ದ ಇಮೇಜ್ ಬಿಹೈಂಡ್ ದ ಮಿರರ್. ವೇರ್ ಆಮ್ ಐ ಗೆಟ್ಟಿಂಗ್ ದ ಇಮೇಜ್? Hang on a second. I am getting the image behind the mirror. Okay, and this kind of image is a virtual image. What kind of image is this? It is a virtual image and it is erect in size. So that is why you call it as an erect and virtual image. So what kind of image is this? Erect and virtual image. I hope everybody has understood this part. I want everybody to give me a thumbs up quickly. Come on. Give me a thumbs up. Excellent. So now that everybody has understood this topic, we will move on to the next one. Next one is a very simple and small topic. Okay. Convex mirrors. All this time I was looking at concave mirrors being reflected. Now I'll do the same thing in the convex mirror. Okay, so imagine that the object is at infinity. If it is at infinity, what is happening? So again, I'm taking the two same rays. Convex mirror also has the same rules only. Okay, so the first scenario is where the light is parallel to the principal axis. Look at this. The incident ray is parallel to principal axis. Again, incident ray is parallel to principal axis. Again, incident ray is parallel to principal axis. Means it is going on principal axis only. Okay. Now, what happens to the reflected ray? The light is getting reflected like this. The same thing is happening here also. We have discussed this before, and this is basic knowledge, where concave mirror is a converging mirror and the convex mirror is a diverging mirror. Correct? Concave mirror is a converging mirror and convex mirror is a diverging mirror. Okay. Now what we have to do in convex mirror, there is no chance of the object meeting at a certain point, is there? ಎಲ್ಲೂನು ಆ ತರ ಮೀಟ್ ಆಗೋದಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ವೇ ಇಲ್ಲ. ಅದಕ್ಕೆ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಅದನ್ನ ಬ್ಯಾಕ್ವರ್ಡ್ಸ್ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಯಾವ ತರ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು ಅದನ್ನ? ಬ್ಯಾಕ್ವರ್ಡ್ಸ್ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ತೀವಿ. ಬ್ಯಾಕ್ವರ್ಡ್ಸ್ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದಾಗ ಐ ಕ್ಯಾನ್ ನೋಟಿಸ್ ದಟ್ ಇಟ್ ಇಸ್ ಮೀಟಿಂಗ್ ಅಟ್ ದ ಫೋಕಸ್. ದಿಸ್ ಇಸ್ ವಾಟ್ ಇಸ್ ಸಪೋಸ್ ಟು ಹ್ಯಾಪನ್, ರೈಟ್? Correct? If the line is parallel to the principal axis, upon divergence or upon reflection, it should come back and fall on the focus. Superb, right? So that is what is happening here. It is going backwards and falling on focus. Now the same thing, like idnalli tumba kammi cases ide, convex mirror nalli tumba kammi cases ide. So idnalli yav reeti case ide ivaga? Look at the second case over here. I am keeping it, where am I keeping it? I am keeping it beyond, like between focus and center of curvature. ಇಲ್ಲಿ ಇಟ್ಟಿದ್ದೀನಿ ನಾನು ಇದನ್ನ. ಓಕೆ, ಅಲ್ಲಿ ಇಟ್ಟಾಗ ಏನಾಯ್ತು ನನ್ನ ಆಬ್ಜೆಕ್ಟ್ಗೆ? ನನ್ನ ಆಬ್ಜೆಕ್ಟ್ ಇಂದ ನಾನು ಸೇಮ್ ಮಾಮೂಲಿ ಎವ್ರಿ ಟೈಮ್ ವಾಟ್ ಐ ಡೂ ದ ಸೇಮ್ ಥಿಂಗ್ ಐ ಆಮ್ ಡೂಯಿಂಗ್ ಹಿಯರ್ ಅಗೇನ್. It is going and falling on the convex mirror and it is reflecting. The second ray is falling in such a way that it is going to the center of curvature. The same thing is happening here. When I extend these two lines backwards like this, I can see that one of them is passing through focus because it was incident parallelly, and the other one is passing through the center of curvature because it was passing through the center of curvature. It clear aitalva? Now, if you take a look at this, this is incidenting at this point A dash, correct? Everybody is with me so far? Give me a thumbs up quickly, everyone. Put out a thumbs up fast. Quickly give me a thumbs up. Okay. So what we have now is this. All right. So it is forming between the pole and the focus. Pole ಮತ್ತೆ focus ಮಧ್ಯ ನನಗೆ ಏನಾಗ್ತಿದೆ image ಸಿಗ್ತಿದೆ. This is where I'm getting the image. Okay. So this is about convex mirror. So let us look at the different cases and see. Yeah. What is happening now? These are the two things, right? Between at infinity, if I keep the position of the object, the position of the image is at the focus behind the mirror. So this is a virtual and erect image, and it is highly diminished. And the second part is the position of the object, that is between infinity and the pole. Pole in the infinity, we're going to any place you keep, I'll always get the image between pole and the focus behind the mirror. This kind of image is diminished and is virtual and erect. Okay, only if you keep at large distances you can see an image in this convex part. Okay, and now we will look at something called as a sign convention for spherical mirrors. So sign convention andre like how it looks like. Okay, so as you know, in graph we have x-axis and y-axis. The same thing is happening here also in the convex, I'm sorry, spherical mirror. That is, this I have taken the example they have taken the example of a concave mirror, and from there onwards we will see how it looks like. Okay, so first one, if the object is kept in such a way that it is standing upright, then we say that its height upwards is positive. If the object is kept in such a way that it is inverted, like when you have take a look at A dash B dash, it's inverted, right, in the second case. So this is height downwards, which is negative. Okay, now if I have a mirror in such a way that I am taking a look at the principal axis, in the concave mirror ಆಗಿರೋದ್ರಿಂದ, in whichever direction the incident light is there, like the incident light is falling in this direction will be a positive direction. The direction opposite to the incident ray is negative. These are the postulates of, I'm sorry, the rules of this thing, sign convention. The object is always placed on the left of the mirror. This shows that the light from the object falls on the mirror from the left hand side. So everything that is coming from left to right is becoming like positive. It is the same as how you do number line, no? It's the same as number line. Okay, and all distances are measured to the right of origin are positive. Origin means what? In this case, it is the pole, correct? And whatever is measured left of origin is taken as negative. This is on the x-axis, and the mirror is like this. This is the y-axis. Above the principal axis, it is positive. Below the principal axis, it is negative. That is along the y-axis. Just keep this in mind. It will be helpful for you in the problems. Like you'll be making use of this thing called as the mirror formula, which is 1 by f is equal to 1 by v plus 1 by u, where f is the focal length, v is the distance of image, and u is the distance of object from the mirror. Always from the mirror. Okay, this focal length, distance of image from the mirror, distance of object from the mirror. Okay, so yeah, about this is exactly where the sign convention that you learned will be used. If v is kept inverted like this, then you take it as minus 1 by v. These kinds of things you need to keep in mind. Just an example I took, you don't actually keep it as minus. So let us try and solve this using a problem. Okay, a convex mirror. Just a second. A convex mirror has a focal length of 20 centimeters. How many centimeters? 20 centimeters. So what is happening now if it is kept there? So it is minus 20 centimeters is the focal length of the object. Okay. And the height of the object is 0.40. It is placed 30 centimeters from the mirror. So away from the mirror. So the image distance and the image height is what they asked me. So I know things about the object. So I'll write whatever is given. So they have given the focal length as -20, height as 40, and D is nothing but the distance. We took it as U and V for image distance and object distance, correct? The same thing here you're doing with D0 and DI. DO is the object distance, DI is the image distance. That's all. That is the only difference between the two formulas. You should be able to use both of the formulas. You should not get confused just because they give what is DI, what is DO. D is the distance here. Okay. If they give it as a U and V also, it's the same thing. If they give it as DI and DO also, it is the same thing. Just the notation is changing. That's all. Okay. Yeah. So look here. I have 1 by F is equal to 1 by DI plus 1 by DO. 1 by di is equal to 1 by f minus 1 by do. Simple shifting I am doing, that's all. Why? Because I need the image distance. I'm just shifting do to the other side. That is what I've written here. So 1 by di is equal to minus 5 by 60. Why? Because they said that f is minus 20 and the do is 30. I am just writing, substituting in place of f and d like this. Okay, this part I'm just substituting it like this. You will get it as 1 by f is 1 by minus 20 minus 1 by 30. If I take the LCM of this and solve, this is 60 is the denominator, and in the numerator I will be having minus 30 and minus 20. Okay, if I simplify this, I will get something similar to what they have gotten here. 1 by di is equal to minus 5. Okay, you can just simplify it at home. I'll give you the method on how to do it. Practice it, like try to do it at home once. Okay. So now minus 5 di is equal to 60. How do I solve this? I'll just shift minus 5 di to the other side. I just have to cancel it. Okay. Once I cancel it, I'll get that di is equal to 12 centimeters, minus 12 centimeters. So this is the distance of the image. So since there is a negative sign with the distance, I can say that I'm getting it behind the mirror because of the negative distance. We learned about the sign conventions, right? So that is what is going to be important. Since it is behind the mirror, it is virtual and it is negative. Minus sign is denoting this. Minus sign is denoting that it is behind the mirror. If it is behind the mirror, it is a virtual image. Next, image height. To calculate the image height, I have a formula called as hi by h0 is equal to minus di by d0. Okay. So you know about magnification, right? So this one is similar to that one, magnification. So hi by h0 is equal to minus di by d0. Okay. So h0 is nothing but object height which they have given here, and I know what is di now because I just found it out, and I know what is do also. Make all the substitutions that you will get an answer. hi ಜಾಗದಲ್ಲಿ ಏನು ಬರಿಬಾರ್ದು ಹಂಗೆ ಇಟ್ಕೋಬೇಕು. ho ಜಾಗದಲ್ಲಿ 40, di ಜಾಗದಲ್ಲಿ -12. This is where most of you will go. Minus di ಕೊಟ್ಟಿದ್ದಾರೆ, ಇಲ್ಲಿ minus where is that, -12 ಇದೆ. So just -12 ಮಾತ್ರ ಬರ್ಕೊಂಡ್ಬಿಡ್ತೀರಾ. No, -12 is for di, not for minus di. So minus of -12 ಅಂತ ಬರ್ಕೋಬೇಕು. So keep this in mind and you're good to go with any numerical problem as it is. So the height of the image is now 16 centimeters because I solved for what is hi. That is image height. Okay. Next, what do I have next? Magnification is equal to hi by h0 is equal to minus di by d0. ಇದನ್ನೇ ನೋಡಿದೆ ಅಲ್ವಾ? ಇದನ್ನ ಇಟ್ಕೊಂಡೆ ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ನ ಚೆಕ್ ಮಾಡೋಣ. Let us check out one more problem so that you will get an idea. So hi by h0 is equal to di by d0. I used it to find out one of the parameters that I did not know, but now I am using it to find out what is magnification also. A 10 centimeter tall flower is placed in front of a concave mirror. If the image of the flower is inverted and it is 7.5 centimeter tall, what is the magnification of the mirror? So it is a 10 centimeter tall flower. Okay. And it is, what do you say? The image is inverted. So I have object height and I have image height. 7.5 centimeter is the image height. That is what is highlighted here. And it's an inverted image. Inverted image ಆಗಿರೋದ್ರಿಂದ ಏನಾಗ್ತಿದೆ? I'm getting it as minus 7.5. I learned it right. If it is inverted, it is negative sign. sign convention. This is where you're using sign convention. So magnification is equal to hi by h0, and magnification will be minus 7.5 by 10.0 centimeter. It doesn't have any unit because I'm comparing between two things of the same unit. So magnification is nothing but minus 75 by 100. Why? ಇಲ್ಲಿ one decimal point ಏನಿದೆ ಅಲ್ವಾ, ಆ one decimal point ನ ಮಾತ್ರ ನಾನು ತೆಗಿತಾ ಇದ್ದೀನಿ. Okay, if I remove one decimal point from the numerator, the same decimal point I can remove from the denominator also. Okay, so yeah, this is pretty much about magnification. Now I have to simplify it. How do I simplify it? Like this. Both of them go by 25. So I'll just cancel it out with 25 using 25 tables. So 25 3 times is 75, 25 4 times is 100. So it is nothing but minus 3 by 4. So the magnification should be converted into decimals. Don't keep it as fraction only, convert it to decimals. Most of all, you will get it as a easily convertible decimal only. Otherwise, just divide and put it up to 3 decimal places like that. Here, 3 minus 3 by 4 is nothing but 0.75. Okay, so this is how I calculate magnification. Hope everybody understood this. I want each and every one of you to put a thumbs up if you understood this. Do it quickly. Everybody put a thumbs up. Come on fast. If you did not understand, raise your hand. I'll unmute you. Which part exactly you did not understand? We will recap it once. Yes. Okay. So yeah, everybody understood the topic. We'll move on to the next one. So this is one of the example problems from your textbook. This one, okay, yes. Someone raised the hand. Yes, Aditya, I will be unmuting you now. ಏನು ಅರ್ಥ ಆಗಲಿಲ್ಲ ಕೇಳಪ್ಪ.
ಇನ್ನೊಂದ್ಸತಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಸರ್.
ಓಕೆ, ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ದಾ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ಒಂದು ನಿಮಿಷ. ಸೊ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ಗೆ ನನಗೆ ಒಂದು ಫಾರ್ಮುಲಾ ಇದೆ. ಏನದು ಫಾರ್ಮುಲಾ? m is equal to hi by ho is equal to di by du. This is the formula. ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ ನೋಡಿ ಇಲ್ಲಿ ಸ್ಕ್ರೀನ್ ಮೇಲೆ. This is my formula for magnification. So ಇದನ್ನ ನಾನು ಈ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೊಂತಾ ಇದ್ದೀನಿ. Okay, how am I using it? ಇಲ್ಲಿ ನನಗೆ ಕೊಟ್ಟಿರೋದೇನು 10 centimeter tall flower. Tall means it is talking about height. So I am making use of the first part of the formula. ಈಕ್ವಲ್ ಟು ಕೊಟ್ಟಿರೋದ್ರಿಂದ ನಾನು ಇದೆರಡು ನಾನು ಈಕ್ವಲ್ ಅಂತ ತೋರಿಸ್ಕೋಬಹುದು, ಇದೆರಡು ನಾನು ಈಕ್ವಲ್ ಅಂತ ತೋರಿಸ್ಕೋಬಹುದು, ಇದನ್ನ ಮತ್ತೆ ಇದನ್ನ ನಾನು ಈಕ್ವಲ್ ಅಂತ ತೋರಿಸ್ಕೋಬಹುದು. ಐ ಕ್ಯಾನ್ ಯೂಸ್ ದ ಫಾರ್ಮುಲಾ ಇನ್ 3 different ways. Okay, I'll be using the first method now. m is equal to hi by h0. ಅದನ್ನ ಇಲ್ಲಿ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ನೋಡಿ. m is equal to hi by h0. So they said that it is a 10 centimeter tall flower. So object h0, object height is equal to 10.0 centimeter. Image height is 7.5, but they told me that image is inverted, so that is why it is minus 7.5 centimeter. Serina? Next I have what is the magnification of the mirror. So m is equal to hi by h0. I'll do only that much. m is equal to hi, that is minus 7.5 divided by h0. ಅದನ್ನ ಇಲ್ಲಿ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ನೋಡ್ರಿ. So there is one decimal place here, one decimal place here. I'm just removing the decimal place like this. I'm just removing this decimal place like this. So I'll get 75 by 100. So that is nothing but m is equal to minus 3 by 4. I'm just simplifying this number. So that is why 3 by 4 is nothing but 0.75. No, minus 0.75 there. So the magnification is minus 0.75. It is a diminishing kind of mirror. Chikkad madutte. Okay, so yes, this time I hope everybody understood. Just give me a thumbs up if you all understood, so that I'll move on to the next topic. So before we start off this problem is going to use everything that we have learned so far. So what all are we using in this problem? We are making use of what is the object distance, what is the image distance, what is the focal length, and we're making use of the mirror formula, that is 1 by f is equal to 1 by v plus 1 by u. We are making use of the magnification formula to find the size of the image. We are checking the sign convention to decide whether the image is a what do you say, a diminished image or an enlarged image, or you know, what kind of image it is, whether it is imaginary or whether I'll get it behind the mirror or in front of the mirror. All these details you can get when you make use of the magnification formula and the mirror formula. Okay, so everybody is so far whatever topics we have done in today's class, that is all the three formulas that we did and the sign convention, you have to be thorough with it. And in the next class, that is the class that is going to happen tomorrow at the same time, 7 o'clock only it will happen. So at that time you can all join in for the class, and there we will solve this problem and we'll finish off lens. That will complete the complete light chapter. Only this part will take a lot of time. Once we get to lens, it is very similar to what mirrors, which is very similar to how we did mirrors, just a slight few changes. I'll tell you how to compare mirrors and lenses so that you get a better clarity of that. So in tomorrow's class we will do lens and this problem. So I'll just end the meeting here. The meeting is going to end automatically anyways. So we'll just wind up the class here and we'll continue tomorrow. Okay, hope you all had a great time today and you understood properly. If you have any doubts, please make a note of it, and tomorrow as soon as the class starts, put it in the chat box. We'll discuss it for 5-10 minutes and then we'll start off with the class. Okay, so we'll just end the class here. I'll see you tomorrow. Bye bye.